Hello, good afternoon, and thank you for the introduction. So I'm Raymond, and my thesis topic is about the impact of green walls on air pollution and thermal comfort. So a bit of introduction is urban center experience poor air quality from transport-related emissions, with 99% of the global population are exposed to it. Additionally, the elevated temperature um, that keeps rising every year, and due to prevalence of artificial low albedo and hard materials such as concrete and asphalt, and also exacerbated by climate change. All these pose threats and risk to health and well-being of the population. Therefore, I need to address this using green infrastructure, but limited spaces exist in urban areas. But however, vertical features can be exploited to integration of green walls, and this is one example of green infrastructure. For the methodology, three scenarios were simulated on NVMet, a CFD simulation software. And as one of the aims of this study is to determine how effective green walls are in reducing air pollutants and in thermal comfort and reducing the mean gradient temperature. So three scenarios were simulated: a base case scenario, a green wall scenario, and a green wall plus three scenarios. London was selected as a reference city, or also called an idealized city, to define the meteorological and pollution data, which is required for the analytical study and to run the analysis. So for the result, strong evidence suggests that the perpendicular wind here with the red box shows that it is the most polluting type of wind flow. In terms of how effective green walls are, the reduction is evident in the afternoon, and it is more effective, 30% more effective in reducing NO2 and 31% effective reducing PM when compared to the base case scenario, and it's effective only at the windward side. You have the leeward and you have the windward side, so it's more, the effect is evident only on the windward side. So in terms of the morning reduction, it's only 8 to 9% in more effective in reducing NO2 and PM. So as I said a while ago, that the perpendicular wind is the most polluting type is because it creates a vortex inside the canyon. So this vortex recirculates and traps the pollution in the canyon instead of dispersing it and mix it with the local air above the building. So for the outdoor thermal comfort, so assessing the effect of green wall on reducing the mean radiant temperature, it was able to reduce by 5 degrees in the mean radiant temperature within the green wall scenario, and further reduction in the presence of trees, but this is localized in the shaded region. So the reduction at 12 p.m. is only 18%, but further reduction of 24 degrees in the mean radiant temperature at 3 p.m. or during peak hours was observed. And in terms of cooling the air with their evapotranspiration, in the green wall scenario, it only reduced the air temperature by 0.3 degrees. Therefore, this suggests that temperature reduction through shading is more effective in reducing elevated temperature. So a bit of mention about the results. So the leeward side is consistently exhibited pollution accumulation, and perpendicular wind shows that is the most polluting wind type or wind flow across the different wind direction. Again, the effectiveness of green wall is only evident on the windward side, and it is more effective reducing NO2 by 32% and PM by 31% when compared to the base case scenarios. In terms of the thermal comfort, reduction was observed by 5 degrees at 3 p.m. or during peak hours. And in terms of also it emitted less radiation in the green wall scenario. When compared to the base case, the green wall is lower by 180 watts per square meter in terms of the radiation it emitted. Therefore, that's why it affects the mean radiant temperature. Again, in terms of reducing temperature, it's the shading of the vegetation is more effective than the air cooling properties. And I think that's about it. But I've got one thing is like the limitation of this study, since my study is about green wall. Unfortunately, on NVMet, the software that I'm using, the green wall module isn't accounting for air pollution, which is funny because that's my study. So the quick fix for this one is to use a hedge as a representative to this one. So therefore, the full potential of green wall was not really analyzed, but it still gave a decent result. So that's it. Thank you.
Thank you very much. Any questions?
I have a quick one. I don't know. Just almost like a comment, a joke, but do you do you cross the road? Do you, when you walk in the street, do you check the wind direction and cross the road to be on the leeward side?
I crossed the road, but I did not really like check the wind. Of course, in reality, the wind direction flows in different directions. So
in reality, it's difficult to predict exactly, isn't it? But it could be a nice idea, no?
yeah.
To have an app that can tell you when to cross the road to avoid the air quality, the air pollution.
Thank you, and for a presentation that's really clear. Two questions. One is you simulated the trees, okay? Yes?
Trees, yes.
So how did you simulate the trees? How big were the trees? What were the coverage of the leaves, etc.? That is one question. The second um, is it possible to simulate also humidity, relative humidity? And how do you think that relative humidity may affect your results from a pollution point of view?
I think I'm gonna answer humidity. Yes, it accounts for. But since I'm using a hedge, in terms of humidity reduction in the green wall, it's lesser by 1.8% only. But because since it would have been more if the module is using a real green wall because there's a soil and the module itself. But since this one is based on a hedge and the soil is only at the ground floor, so therefore the humidity level is lower, but it would have an effect on the wind itself and the temperature. So yes, but unfortunately it doesn't, the green wall on the software doesn't account as of now, so it is still not that the reduction is still not that significant. And in terms of the trees, yes, there's also the trees that simulated, and a specific type of tree is also available on the software. And the coverage range is, if I remember, is about 9 meter spread. But the result, I was expecting that it would accumulate more pollution, but when I checked the tree properties, it has a LAD of 1 to 1.5, which is lesser. So it means that it was able to allow more airflow, so it didn't trap the air as compared to previous studies.
You show the canyon as being rectangular at the top, and is that to what it, and the same both sides?
Sorry, this one. This one.
No, the actual street you did it in.
Oh, okay. The street is actually so of course you need to build the street canyon. So it was in order to build the street canyon. So even though I didn't mention this one, so part of the methodology is to analyze several streets here in London to build the canyon itself. So I need the study need to analyze what is the typical building height or aspect ratio, and then once I have that data, I was able to build the street canyon, which is, so it's not exactly a street in Marylebone, but it is the sum of all the mean building height and width of the road.
You have to be a bit careful, because I took part in a study in Athens, where it was assumed that when the wind was going across, that it went in and down and out again.
Yes.
When it was actually measured with, measuring it was pretty well random, because there's never exactly the same height, or so I would be a bit careful about your simulation. I mean, I'm not saying the results are, but they may be for something other than the fact that the wind is doing that. See what I mean?
Yes. Because also it could be affected by, since I only have 2 canyons here, so it could be different with other buildings there. But since I'm want to like isolate it and see what is the effect of that particular wind flow only, so that's why it's quite isolated, not like considering the external buildings. But it would have a different effect, of course, if you have the surrounding buildings included in one. And it makes the analysis even more complex.
Unfortunately, the roofs tend to be that shape in London.
Also, yeah, the shape of the roofs also have, but then we want to have the basic one to understand how this simple wind.
They're very difficult to simulate accurately.
Thank you very much.